In this chapter, we'll be discovering what are API routes in Medusa. Let's decompose our store custom endpoint and actually create custom store suppliers endpoint. We can do that by creating new folder in a store folder, let's call it suppliers, and in suppliers folder create new file called route.ts. To create new endpoint under the store suppliers namespace, we should export the function from that file with the HTTP method in the name. In our case, it would be get. Let's resolve supplier service from the dependency container, and also let's not forget to use the generic type to get typings of that service. Let's use that supplier service to list all the suppliers and return to the client. I also want to mention that Medusa not only allows you to use get HTTP methods, you can actually use multiple of them, like post, like put or patch, and etc. Let's not only have the endpoint for listing all of the suppliers, I also want to have an endpoint for retrieving specific supplier by his ID. For this use case, I will use the pass params in Medusa. I'll create new folder with brackets and ID in it and create a new file route.ts. I will copy the listing suppliers endpoint and only modify the import. And also I will assign an ID from the pass params from the request. And what we see, we do not have a retrieve method in the supplier service. So let's add it. And now we can use this method to retrieve specific supplier. Let's also not forget about changing the variable name from suppliers to supplier. Let's also add an endpoint for updating specific supplier by his ID. I will copy the get function and just change the name to the post. And also let's add an update method that would actually update the supplier by his ID. I will use two parameters, ID and data. I will remove the usage of supplier repository for retrieving the specific record. Instead, I will reuse the retrieve method from the supplier repository to do the same. Now let's iterate every key in a data object and replace old values with new, and then later use the save method in the supplier repository to actually save the changes in the database. If we hit the store suppliers endpoint, we would return two keys with the same name, so one of them is unnecessary, so let's fix it. Instead of returning an object, let's return a tuple in which as the first element it would be the list of records and the second element would be the total count. Now let's refactor our code in endpoints and just add count in the object response. Now I get TypeScript error in store custom endpoint because we refactored the method. I will just fix it by removing the response in the endpoint. Now if we hit store suppliers endpoint, we would see beautifully display data, suppliers and count. Let's refactor updating the supplier endpoint, which is suppliers ID, and this is a post request. I will use the update method from the supplier service, and in method as the update body, I will provide the request body. Let's take a look if update works, and if I provide the name for the specific supplier, it actually changes, and we actually can see it in the response of the request. Let's create new method in the supplier service, which would be responsible for saving new records in the database. I will use the create method from the supplier repository and also save method. And now I will go to the store suppliers row.ts file and add a new post method, which would handle the creation of the suppliers in the database, and we'll be utilizing the create methods. But now we have a problem that we can send any form of request body and it would pass to the database level and could potentially lead to some errors and vulnerabilities, so we should definitely fix it. I will create a new file called validators.ts in the suppliers folder, and also I will create in that file new class called store post supplier request, and I will use the convention of adding a scope of the endpoints. In our case it would be store, the methods, and the entity name. I would use a string decorator in order to test if name field is actually a string. So now I can go to the store suppliers post methods and import validator function from Medusa.js Medusa package. I also want to draw attention that validator is a promise, so we should use await before using that function. And as the first argument, I would pass the validation class, and as the second argument, I would pass the request body. And the validator actually returns a validated data, so we can actually paste it in the create method. Now let's do the same procedure with the update endpoint. I will copy the validation logic in the update endpoint, and also I should create a new validator specifically for the update endpoint. It would be much the same, except I will use the store post supplier request convention, in which I would pass the same values which is in the create validator. Now I will import the validator function from the package and also the validation class. Let's not forget about passing the validated data in the update method. If we try to send in proper data form, we would get an error and the 400 status. So we should change it to the proper and to use name field with the proper string. And now we would see a 200 request status. Let's finish our crude store suppliers endpoints and add new deletion endpoint. I would create new method in the supplier service. Also notice that we are using the soft deletion in our entity model. Here we are extending from soft deletable entity, so we should use soft delete method instead of delete. I will continue by adding new delete method in the endpoints, and I would use the supplier service delete method. And also let's change the response to success true instead of returning the deleted supplier. And now let's test in the postman. I will delete specific supplier, and now we can see the success true. And now if I would try to retrieve the specific supplier, I would get just null. Also, we cannot see the specific record in the list endpoint. But hey, I don't want to return 200 request status with the null in the supplier property, so I should definitely throw some error. In order to do that, I should import Medusa error from the Medusa core utils package. Actually, let's also fix the relative pass in the supplier models import. And now I should specify the Medusa error type. In our case, it would be not found. And also as a second argument, I should specify a message that supplier is not found. Also, I want to show you what it would look like if we would not use the Medusa error and just use default error in the JavaScript. And I would provide the supplier not found message. Let's start the backend. Let's head to the postman and test our endpoint, and we get an unknown error. And that's because Medusa treats non-Medusa errors as the potential sensitive information, so it marks them as an unknown error. I will remove the error and go back to the Medusa error, and let's see how does it work in the postman. Now, when we hit the endpoint with non-existing supplier ID, we would get the 404 status, the type of not found, and the correct message. As Medusa is a headless commerce engine, it comes with the already built endpoint groups. The first endpoint group type is the store, and the second one is admin. Store endpoint group is typically used on the storefront. So for example, reading of published products, reading of me as a customer, my orders, reading my cart, updating my cart, and reading, for example, region. So you can imagine it as a customer related logic. Another group we have admin endpoint group that is used for the managing orders, and not only my orders but all orders in the store, reading products, editing products and deleting them, for example, managing regions, store configuration. As we don't want to allow customers to manage our suppliers in the store, we should definitely move the suppliers folder into the admin in order to allow only admins manage the suppliers. Cool, let's now check how does it work in the Postman. If we hit the store suppliers endpoint, we would get 404 status. So let's check the admin suppliers. And as we can see now, we get 401 status. That means that we are not authorized to do that request. In order to log in as an admin, we should hit the admin auth endpoint, and we should provide the credentials that we were using for initializing Medusa in the first chapter. If you followed me, the credentials would be email admin medusatest.com and the password would be super secret. If we hit this endpoint, it would create a new session and attach it to the cookie, and now we can actually access the admin group. As you can see, we can create new supplier and get a list of suppliers, so all of that supplier related logic works. Also guys, I want to show you that not only admin API group is required for authentication, but some of the roles for the storefront. For example, the store customer's me. Even if you would try to access the endpoint with the prefix of store customer's me, you would still get an unauthorized error. In case if you want to disable the required authentication in the admin folder, or for example the store customers me endpoint, you can use the authenticate flag, which would opt out the required authentication. And now if I go to Postman, even when I clear all of my cookies, I would still be able to, for example, add new suppliers. The next thing I want to show you guys is the middlewares in Medusa. For those who don't know what the middleware is, it's an action that runs before the route handler and, among other usages, could modify the response of an API route. You can imagine a situation when you want to return 401 status if the user is not authenticated, and you can do it using the middlewares. In order to create our first middleware, we should create a new file called middlewares.js in the API folder, and I've just actually copied an example of middleware in Medusa from the docs, and as you can see here, I've just created new middleware that opts out the course configuration under the matcher. I will change it to the admin suppliers. Let's remove that course opt-out and create our first new middleware. We can do that by creating a new function that takes 3 arguments, first of which is the request, the second one is the response, and the third one is next function. If the next function is executed, it will proceed to the route handler. Let's pass that my custom middleware in the middlewares array. I will hit this endpoint with the postman, and now when I go to the console, I see the log from my custom middleware. Medusa comes with the default middlewares, like for example, require customer authentication, which by the name you can understand what it does. The next customer authentication middleware is authenticate customer. What it does, it registers the customer in the request, but it does it optionally. So for example, if you don't want to require a customer to be authenticated, you can use that middleware. The next authentication middleware in Medusa is authenticate, which is quite the same with the required customer authentication, besides it works only on admin users. The two previous middlewares only works for the customer. If you want to, for example, require admin user authentication, you can use authenticate middleware, and it requires the authentication for the admin users. I also want to show you guys how the registration of a customers in the request works. So I will use the require customer authentication middleware under the store custom endpoint. Let's also remove some unnecessary imports. And also let's add the console log of request.user in the store custom endpoint route handler. Before testing the required customer authentication, we should authenticate as a customer. So I will create new customer with that data. And now as we have authenticated customer session cookie, we can hit the store custom endpoint and see the console. And we have an object in which we have customer ID as the authenticated customer from the session cookie. You might have the situation where you registered a resource in the dependency container, but you want to, for example, access it in a service. On every request, Medusa creates a new scope in the container. So Medusa creates new scope of the dependency container on every request. So you can register some resources in the dependency container and only access it in the scope of the request. Let me show what I mean. For example, I want to know what exactly logged in customer looks like when he accesses some methods in the supplier service. So I will create new property customer and assign this property from the dependency container. I will add a console log on the retrieve method because we use that method in the endpoints. And also what I should do is wrap the assigning of the customer from the dependency container with the try catch. It would avoid the error on the Medusa start. Let's also change the property name from customer to logged in customer to be more precise. Medusa codebase uses a convention in the properties and adds the underscore in the end of it to mark it as a private. So I should do this too. Let's create a middleware that would access the logged in customer and then register him in the scope of the dependency container of the request. I created a new folder called middlewares, and also in that folder I would create a new file called register logged in customer.ts. And now this should be a function that returns a function which takes three arguments: request, response, and the next function. Now what we should do is access the customer ID from the request user property, and then using the customer service retrieve that logged in customer and then register him in the dependency container scope. Let's assign customer service to the variable of customer service. Also, let's not forget about providing a type definition from the Medusa package of that service. And now we can retrieve that user using the customer ID. Now, using the request scope register, we can provide the registered resource name. In our case, it would be logged in customer. And as a second parameter, we would provide a resolve function that would return this customer. Also, let's not forget about executing the next function in the end of the middleware to proceed to the route handler. And also, let's make a statement if the customer ID could not be accessed from the request user property, it would throw the unauthorized Medusa error. I will add new endpoint called store suppliers and provide the same logic from the admin suppliers get request to retrieve suppliers. Let's provide correct imports. Also, let's fix the relative imports to not have any errors. And now I will add a console of this logged in customer into the list and count method of the service. As we provided the resource name of logged in customer and not just customer, we should change the name in the injected dependencies. Let's go to the middlewares.ts file and add a new middlewares to the store suppliers endpoint. We can do that by providing the matcher of store suppliers and adding the array of middlewares one by one. The first one would be authenticate customer, and the second one would be register logged in customer. Let's import from the middlewares folder, and also let's change the path to relative. Now, when I hit the store suppliers endpoint and go to the console, I could see the list and count message with the customer object, which depends on the authenticated customer in the request. Also, guys, I want to warn you that if you're extending the Medusa default services, like for example product service, due to the fact that Medusa default services are cached in the dependency container and they are using the lifetime of singleton, if you are registering some resources in the scoped dependency container and you want to access them in the default Medusa services that you are extending, you should change the lifetime to transient or scoped. In that case, you opt out the caching of the dependency container. As I have shown you before, Medusa comes with default API endpoints for the storefront and the admin panel, and you might have a case where you want to change some of the validators of API endpoints. For example, admin products. If you would visit the Medusa core repository and check the admin products endpoint for creating products, we would see that there is admin post products request class that is responsible for validating the body request. I want to show you how you can extend it. I will create new folder in the admin directory called products and place new file called validator.ts in that directory. I follow this convention to be able in a future identified what validators are related to what endpoints. In our case, it would be admin products. And what I should do is create new class called admin create product, and I would extend it from the Medusa admin create product. Let's import the Medusa admin create product from the API folder. And actually it's admin post products request instead of admin create product. So I will change it to Medusa admin post product request. Now I would be able to extend validation class with the additional fields. It could be actually anything. So I will use additional field as the key name. And also I should import the isString decorator from the class validator package. Now what I should do next is create new index.ts file under the API directory, import the register of read and validators function from the Medusa package, and then execute it with the class that we actually created a second before. In our case, it would be admin post products request, and also let's not forget about importing this class from the API admin products validator file. Now I should log in as an admin using the admin auth endpoint, and also I should hit the admin products endpoint in order to create a product. I will provide some test data like name test, but the response status is 400 and it's telling me to add additional field which must be a string.